call, I just say execute. And when it executes, it's going to be given a callback. So this callback function just takes the response, and I'm setting it, this is the closure I was talking about, I'm setting it to the external variable so that after I make this call, we can actually interact with the response object. So here's the response. So what I've done, I've taken an existing short URL, and I've made a GET request to the URL shortening API. So what do I expect to get back? I expect to get back all this metadata about the short URL. So we still have the ID, we have the kind, but now we have the long URL, which is, as people might have noticed, the long link for this slide is cloud-endpoints-roadshow.appspot.com. Okay, so it's really that easy, that tiny bit of code to actually interact with a Google API using JavaScript. All right, so now we're done inspecting all the things. Now how can you do this, or yourself? So a bit of an overview about what you're going to do when you use cloud endpoints. I made a tic-tac-toe app, so this is a tic-tac-toe review. Lame joke, I have more. So first you write your back-end code. So for tic-tac-toe, all we're doing is interacting with the board and scores for individual players. So you're writing your code to actually handle this stuff in the back end, right? Next, you're decorating your API methods. Today I'm going to be using Python. I think Python is great for presentations, even if you don't like Python, because it reads like pseudocode. But in the Java world, annotate would be the word I would be using. But in general, it's you have some sugar and you sprinkle it on your methods, and now they know how to talk to APIs, right? Then you generate client libraries. As I mentioned, we have client library support for a ton of languages, right? But for dynamic languages like Python and JavaScript, you don't have to generate anything. They can just create classes and make stuff up on the fly, right? But for compiled languages, it's not as easy. So for Objective-C and Java, instead of consuming the discovery document on the fly, you would consume it offline and use our library to have some machine-generated code that would accomplish the same thing that the JavaScript loader accomplished. Again, you don't have to write it, but it is a bit different if you're talking how synchronous or asynchronous it is. And then, of course, you write your client-side app. So this is the CSS, or the mobile equivalent of CSS styling. So let's actually play. What does tic-tac-toe look like? So first, you might have noticed, I started signed out, and now I'm signed in. And so I'm not going to talk about auth today. If people want to talk about it later, I'll be available. But this application, using the JavaScript client library, detected some cookies and actually found out, oh, I've already signed in before, and then it signed me in asynchronously. So it did all that work for me. I didn't actually have to do a whole lot. And then below, it tells me a list of all the results I've had. I've had some ties, but they weren't in the most 10 recent times I played the computer, okay? So let's play. So I just put an X, and then what happens is somebody at Google saw that I played this, and then they type no and send it back to me. Anyone ever seen the April Fool's joke about how autocomplete works? No, that's not what actually happened. So let me keep playing. I'll explain what happened in a bit. So obviously, whoever's playing is pretty bad. So I just won without really trying, right? So who is playing? The API is who's playing. So what actually happens, and I'll show you in code, is the API is, it's running on App Engine, and it sees a board that we send it from the client, and it knows there's some empty spaces, so then it takes a blindfold, puts it on, and throws a dart at those empty spaces. And as you saw, that doesn't usually yield good results. So how does this actually work? We're just trying to make something that works, not something that's good. But maybe for your users, if they win all the time, that's good. I don't know. This is a lot of code. I don't want you to look at all of it. A few things I want to point out. So using the endpoints library that's provided, there's a method called API, and this is how declaration works in Python. You just put an @ sign, and you give it a method, and then you throw some metadata in there. So this is actually on a service class, which is going to be the API itself. All the methods are the methods for the API, right? And so the name of my API, tic-tac-toe, the version v1, and the description, in case any human tries to read, tic-tac-toe API. Now I hope no humans try to read my discovery document, I just want computers to read it. So in my first method, again I have a decorator, endpoints.method, some more metadata below, but importantly at the very beginning I have two classes. It's actually the same class, but they represent the data in the request and the data coming out from the response. And I define this below. Board message is a special type of class. This is something we provide via a library called proto-RPC that handles compression, that handles the wire format and all these other things, and all you tell it is, okay, I need a string, and it's going to represent the state of the game. So we actually don't have to worry about auth here because the computer just has to see a game and do something, right? It doesn't actually care who the user is. Maybe some future version we want it to be easier on certain levels of players, but for now, we're not going to spend our time with that, right? And so the game state, which we'll actually interact with in a second, is just a string with 9 characters, X's, O's, and dashes. And dashes are the dartboard that the computer is throwing darts at, right? Dash means no move has been played yet. So how does it play? It gets the move, it reads the state, makes sure it's valid, and then it calls a method on itself called add move to board and sends it back as a board message and it sets the state to that value. Okay, so what does add move to board look like? This is great. This is much longer in Java, but in Python it's only a couple lines. So first, it goes through the board state and finds all dashes, and using the simplest regular expression you've ever seen, match one character, right? And then from there, it uses the random library from Python and calls choice. So if you give choice a list, it just gives you back something random from it, right? Some random place within the list. And then that's going to be an index, because that's what we're matching with a regular expression. And then we set that index to O. And now, result, I didn't mention, we take a string which is not mutable, immutable, and we make it mutable by converting it to a Python list, so we can actually set part of it. And then finally, at the end, we just turn it into a string and throw it back, okay? So, cool. We have our own APIs Explorer for this application. So this is not the same link. It has a special base, which is my application. I didn't mention this, my application is a nonsense link, but my app ID is just some random hex string, and .appspot.com is the domain that all App Engine apps live on by default. So I have my own discovery service. So if I call the discovery service with my API name, tic-tac-toe, and the version, what do I get back? I get back a discovery document. I'm scrolling on the wrong part. And it gives me all the things it can do. So I have 2 resources, board and scores. We're not going to talk about scores, but later I'd be happy to show people. And board has this one method, get move, right? So if we actually interact with get move, we can give it a board. So first row. So the way it's working, the first 3 characters, the first row, next 3 is the second row, last 3 is the third row, obviously. So let's say the human player has played in the top corners, the computer player has played first position in the second row, and then nobody else has played. That's hopefully nice. So what happens? It just gives me back another string representing the new state after it's played. And if we executed this a few more times, we would see it really has no idea what it's doing. It's like, whatever. Yeah, that's right. I can make a move. Okay? So, one last thing I want to talk about before wrapping this talk up is how we can make a smarter app. A smarter AI. That was my other bad joke. Nobody likes it. So, instead of putting on the blindfold, let's do one other thing. So, some methods which I've defined, which we're not going to go over, can win and can lose. It takes a board state, can win, says, okay, is there any position I could play in and win the game? And if it is, it returns the index of that position, otherwise it returns a null object. Similarly, can lose. Is there any position I can step in and keep from losing the very next turn? And if there is, it returns the index, otherwise it returns a null object. So this variable can complete is going to be, first, the index of the winning move if one exists. If not, it'll fall over via the OR statement to the position of the lose preventing move. And again, if that's null, then can complete will be null, and this first if statement won't actually execute. We'll get back to stupid computer, right? Otherwise, it'll set the winning or lose blocking index to O and just return that value, okay? So we've made it smarter. Let's actually make it smarter. I'm going to pull up the terminal. So there's the old method. I've just pasted over it and deleted it. So here's this method we just defined. Those are the can win and can lose methods that we're not going to talk about more. And I can actually deploy a new version of my application by going to the App Engine launcher. And just clicking deploy. So while this deploys, a bit about this launcher. This is a tool that's intended for App Engine developers. It's super, super useful. You point it to a location on your file system. So here, my app lives users, D, Hermes, endpoints, trusted testers, Python, tic-tac-toe. And so I point it at that application, and it just tries to deploy an application to Google App Engine from there. And so what's it doing? So first, it uploads all of my code. And it actually does it intelligently. It won't upload things that it already has. It just kind of uploads the diffs. And then it checks if a deployment has succeeded. So I mentioned App Engine is a higher level abstraction than a virtual machine. But you still have this concept of an instance. And when you're scaling requests, you're doing it with more instances. So when it checks if the deployment has succeeded, it's checking if it actually can create an instance with your code. It doesn't mean when requests hit your code, errors won't happen, but it does mean that it can successfully create something to run an application. Maybe you're terrible at programming, but you did good enough to have something that runs, right? And then after it figures out it can create instances, it checks if instances are able to serve requests. So I had a question about this recently. People say, what happens if you deploy over your application while it's running? Well, there's some time, this time, to actually check if updated version is serving, that if you deployed over your app while it was running, you would get 500s. You know, there'd be nothing to hit, right? This can take a bit of time. Believe it or not, I've been talking for 48 plus seconds about this stuff, as we see in the log. Maybe you can't see that if you don't have great eyesight. But it should be done relatively soon. But anyhow, this is just one of our tools for actually working with App Engine applications and deploying them. Please finish. Please finish. This is why you don't do demos like this when you give a talk. Yay, it finished. Okay, so it says completed update, exiting with code 0, which for people who know, that's good. So cool. So my application has updated. Let's go back to it. Let's play against Al. So I'm going to do the same stupid move. Okay, he didn't know about winning and losing. He's just like, whatever, or she, or it. So now I do this. Aha! So at this point, it can actually, block me winning. But unfortunately, since its first move is so bad, if I play here, then it can only block one of my winning moves, and I win. But if I don't pay attention, the computer can probably block me. No, we're gonna end up in a tie here. Yeah. Anyway, it got a lot better, right? So I'll show you before I wrap up and move to questions, what's actually happening each and every time. If we give it that same board state, there's only one correct play every time, right? It's block the human from winning. The human should never win, okay? And that's what it does. So we made our game better. Thank you for coming to listen to me talk. Please try out Google Cloud Endpoints. You can find the slides at goo.gl2gtej. If you'd like, give me some feedback. We might send you a cool App Engine plushie. That's the logo in 3D form. Some other links if you're interested in our client libraries. And then at the very bottom, if you're interested in signing up for the Trusted Tester program. But you just need one link, because all of these live on the interwebs. So thank you. We have time for questions.
Maybe one.
Okay, 1 or 2. I'll be at an office hours from 1:10 to 2, but I think I'm the only guy wearing this color yellow. So, if you find me, come talk to me.
For scaling, do we need to tell it how much to scale, or
It just knows. It's built for scale. So if the instances it has can't serve the traffic it has, it just creates more. And similarly, if the instances it has aren't working, it kills it until you get down to a number that's the number that you want.
I think you might have covered it, maybe I missed it, but if you wanted to persist the results of, say, tic-tac-toe, is there a key value database like Google?
That's the NoSQL data store. That's exactly what it is. It's key value. So I showed this board move method that returned a board message with the new game state. Instead of just returning the board message, you would just at that point persist it, right? But that would be up to you. It doesn't do that by default.
what is the best practice to ensure that you can do it like a stage deployment, like acceptance or
Yeah, so we have versions. I didn't show there's an application file where you have a bit of metadata. It's pretty much just like your application ID, which in my case was 3F nonsense, right? And you have a version for your app, and you also have like URL handlers that tell you which scripts are supposed to handle which paths, right? But the version is how you would do this. So if you deploy a version, when you go to the administration console for App Engine, there's always a default. So you can have 10 versions deployed at the same time, and if you don't deploy the default, users won't be able to see it, but you can still go to that default version. If you deploy it, it's still up on the web. So you can do testing, you can
roll back.
you can roll back, you can just delete that particular version that you updated. There's all kinds of things like that. So you can't actually roll back a change to a given version, but I would highly recommend not deploying over an existing version if it's serving traffic. For the reason that I said, you may have 32 please, please, please finish seconds while it hasn't served yet after deploying. So what you would instead do is deploy a new version, make sure it works, make sure you like it, and then set that to your default. And what will happen is just any traffic that comes in hence after you've changed the default, going to the default version, any traffic that was being served by the old default, those requests will finish, and then all those instances will no longer be serving those requests. I think that's it for questions? Okay. So we can chat like right now, but I have to stop taking questions. So thanks everyone. It was great making this talk. Well, it's